Good afternoon, everybody. My name is Mark Halliwell. I've been with Taggle Systems now for almost 6 years, and I'm here this afternoon to give you a short presentation, our weekly Wednesday afternoon webinar, and the subject today is going to be smart water meters. What I'd like to do first, though, is for those of you who haven't learned much about Taggle in the past, is just to give you a quick overview as to who we are and what we do. This won't take just a couple of minutes. The idea being to bring everyone up to speed, get them all on the same page. So Taggle got started in about 2007, and we've made a bit of a name for ourselves in the area of smart meters. The technology developed by the company, it's low power wide area technology, so great advantage in the area of collecting small amounts of data from large numbers of devices spread across wide geographies, and water meters are a great candidate for that. And since working with our first big customer, Mackay Regional Council, in about 2010-11, the company has gone on to become Australia's foremost provider of smart metering systems, automatic meter reading systems, as well as providing the network for use with other telemetry applications, which I won't go into much today, but I might just refer to it briefly. The situation today is that we have approximately 200,000 devices on our network, which is offered as a managed network as a service. And of those 200,000 odd devices, probably about 180,000 of those are actually smart water meters of one sort or another. We currently work with about 45 water service providers around the country, some of whom are still engaged in pilot studies and trials. But as we have found out, as we've discovered in the last couple of years, there's less and less trials going on now, and more utilities going straight into a full rollout or a full deployment of a smart water meter reading system. Indeed, in the last 2 years, I don't think we've started any trials, but we have had, 5, 6, possibly 8 different councils go straight into full rollouts. So that really is a good indication of the maturity of automatic meter reading in Australia, and a great boost, if you like, to the reputation of Taggle Systems, in that we have so many of our customers just saying, go ahead and put it in. So this is a bit of an overview of how our network operates. For anyone who's familiar with the SCADA system, it's not dissimilar, in that you have on the left-hand side of the screen sensors, which are all out in the field, spread across wide areas, each of which is fitted with a Taggle transmitter, or may have one fitted inside it. You move across then to the communications section, which is the Taggle receiver network. This one-way communications network is unique in Australia, in that it's the only one designed specifically for this type of application, and features a network of receivers, each of which has an extremely sensitive radio receiver on board to pick up the very, very weak signals coming from the various sensors and transmitters. That data is typically transferred to the cloud using a mobile phone network, a VPN over mobile phone, although in the Northern Territory we do have some satellite-based receivers which transfer their data via satellite into the cloud. Once the data is in the cloud, it goes onto Taggle's IoT platform, our back-end system, if you will, where all of the data is processed to deduplicate and package up ready for sending to our customers. The data is delivered in a number of different formats, from as simple as a CSV file delivered by FTP, through to all sorts of APIs, and indeed including the use of DNP3 protocol for SCADA systems. Once our customers have the data, they can then use it in whatever systems they want to use that data, whether it be a billing system, GIS, SCADA, hydraulic modeling, whatever it might be. It's their data, they get to use it as they wish. Of course, we would prefer that all of our customers use Taggle's own meter data management platform, which is called Aqualis. Used to be called MyWater, but as of tomorrow, I believe it will be Aqualis. So that's where we would see most of the data going from our smart meters. These are just a few photographs of Taggle in action. I won't go into the details of each one, but you can see that there's a range of different type of installations and applications, including on the bottom right-hand side, rain gauges and sewer level sensors. But I won't be talking much about those today. We're here to talk about smart meters. And just to give you an idea of where we work, this is a snapshot of the logos of all of our customers, or maybe not all of our customers, but certainly the majority of them. It's quite a who's who of the water industry in Australia. So let's talk about smart water meters. What exactly is a smart water meter? Well, a smart water meter is really just one of the millions, if not billions, of sensors that go to make up, or will be going to make up, the Internet of Things. And the Internet of Things is really just, well, I've made reference to the word SCADA. It's a bit like SCADA on steroids. It's really just sensors, communications, data, processing that data, and then making decisions. So smart meter is essentially a sensor fitted with some communications intended to send data back to the water service provider for their processing. Now, there are two schools of thought on smart meters, and if you travel around the country, particularly down in Victoria, you tend to get one flavor and the other sort of coming head to head. In the rest of the country, not so much. But of the two schools of thought on smart meters, the first one is quite sophisticated. In addition to collecting meter readings, it'll do tamper detecting. It might have inbuilt sensors such as pressure or temperature. They usually have two-way communications. They might use a mesh network type of setup, maybe not. Invariably, they involve multiple data resends, which becomes important when we get on to talking about some of the pros and cons. They also have inbuilt flow alarms, and really they're devices which have microcomputers built in to produce or provide what is referred to often as edge computing. That is, the data is collected at the edge and it's processed, and what gets sent back to the utility then is the result of that computing, whether it be an alarm or a reading or whatever it might be. Very often these types of smart meters also have considerable data logging abilities. The second school of thought on smart meters is what I would refer to as the KISS type smart meter, the keep it simple stupid type smart meter. They produce meter readings. They too would have a tamper detect alarm, and in the case of Taggle Systems, one-way communications. So I've already given you the clue, but Taggle Systems' approach to smart meters is the KISS principle, the keep it simple stupid principle. That is to simply send water meter readings, to send information about the physical tamper detect system that's on the meter, and not much else. And the reason for that boils down to one simple factor, and that is cost. With a smart meter, or with a smart meter network, or an automatic meter reading network, and you're looking at a business case for a smart meter network, the biggest single item of cost in any of that is the water meters themselves, the endpoints, the devices that are water meter with either inbuilt or external transmitter. In the case of Sydney Water, for example, they've got 1.3 million water meters. So it's kind of important to get the cost of the endpoints to a minimum. These points are the most numerous, and when you consider the components that go into them, it's the battery that's the most expensive component. And what drives the size of the battery in an endpoint, such as a smart water meter, is the demands on the smart water meter, whether there's computing requirements, data logging requirements, two-way communications requirements. All of these things go to adding to the cost of the battery. The bigger the battery, the bigger the cost. And you know, if you consider a 100,000 meter fleet, every $10 that you add to the cost of every single meter adds $1 million to the cost of your project. So you can consider your own water service provider and your own fleets and consider what it might cost for every $10 that you add to the cost of a meter. It's quite significant. So from Taggle's point of view, the aim of the game is to keep the cost of the endpoint to a minimum. This creates a better opportunity to have a positive business case and means that you're going to be able to deliver more for less. The other key to all of this is that whereas the Type 1 smart meters that I described do their processing at the edge, at the actual meter, Taggle's view is that if you collect the raw data, you can process that data in the cloud in any which way you like. You can change set points, you can change parameters, you can change periods or whatever it might be. All of that can be done in the cloud. And it's far less expensive to have a computer person sitting behind a keyboard making these changes, doing what-if scenarios, than it is to try and update, tens of thousands, hundreds of thousands of meters across the airwaves, chewing up batteries every time they do that. So Taggle's approach is to keep it as simple as possible and keep the cost down to produce a positive business case. Looking now at the individual devices that Taggle manufactures and provides as part of its managed network as a service, we're looking here at an MRC1 type transmitter. This device was developed in conjunction with Mackay Regional Council, hence the name, and was intended for use with Elster V100 meters. The Elster V100s are the most widely used domestic 20mm meter in Australia, and so it made sense for Taggle to develop a device that was built for the device. When they are installed, as you can see in the photographs on the right, they almost become part of the meter. The green color sort of blends in with the fading brass or the tarnished brass. There's approximately 90,000 of these, actually more than 100,000 of these. I just checked a few minutes ago. There's about 107,000 of these installed around Australia. The little prong that you see, or probe that you see on the left-hand side, is an integrated Hall effect sensor. Those of you that know the Elster V100 would know that the native Elster probe is a reed switch, but Taggle saw fit to include a Hall effect sensor to make it a little bit more reliable. These are intended primarily for residential applications, as you can imagine, being a DN20 meter. A counterpart of the MRC1 is the ADC1, which is effectively the same transmitter, but it's housed in a more generic kind of housing. And the reason for that is to make it into a generic pulse output type device. That is to say, it's capable of, it's suitable for use with devices which have a pulse output. And that includes pretty well all meters. So any meter that has a pulse output, we can use an ADC1 transmitter with that meter, or indeed other device, and have the data sent up into the cloud. It provides great flexibility and means that particularly where you have a long lead, if you have a situation where a meter's in a pit or it's in a basement or whatever it might be, you can remove the transmitter to another location, that is to put the transmitter at a location away from the meter and get the best available radio connectivity from there. The HP1 is a high-powered version of the ADC1, and this is something somewhat unique to Taggle. I don't believe there are any other smart meter providers that have a device such as our HP1, which give us a great advantage when we find ourselves trying to get data from meters in basements or perhaps in pits or other awkward sites where getting a radio connection is just impossible. I've seen these in use in the basements of buildings 3 levels deep, and we're still able to get a signal out to the area around it. We did a trial for Sydney Water some years ago, where while we were focused on trying to get them to have a look at what we're doing in a high-rise apartment building, they were more interested in putting these into the basements of commercial properties around the high-rise building. And even up to half a kilometre away, we were able to get signals coming out of the basements of some of the buildings. So this device is extremely valuable to Taggle and helps to provide coverage in areas where otherwise we couldn't. So when you look at the ADC1 and HP1, they don't connect directly to all of the various meters with which they work. It's necessary to use what we call meter interface units. And different meter manufacturers have different types of units or probes, as some people call them. We have worked with pretty well all of the ones that are available in Australia. And here is just a snapshot of a few of them. Probably the most commonly used one is the T probe from Elster, suitable for use with any of its V-series meters, the V100, V200, V300. But we also work with devices from RMC, from Itron, and many other meter manufacturers. This gives Taggle great flexibility when retrofitting its transmitters to the fleets of utilities where it's not intended to replace the meters. If you've got an existing fleet and you want to have them part of your AMR system or your smart meter system, it's very easy to take these devices, connect them to an ADC or an HP1, and have that data sent up into the cloud along with everything else. The last of the Taggle transmitters that I'll talk about for the moment is the LSTT. This is a general purpose transmitter, but it's aimed at devices or meters that have either analog or serial inputs, outputs I should say. What I mean by analog is, for example, a meter that might have a 4 to 20 milliamp output, or perhaps 0 to 10 volts. Alternatively, it could be a serial output, such as Modbus, as you find with, for example, Krone meters or Siemens meters or others. Being suitable for use with analog particularly makes the unit very well suited to use with other types of sensors. Shown in the photographs on the right, at the top you have a weather station, which actually uses SDI12, a form of serial output. Below that is a chloroclam residual chlorine device, and below that again then is I think that's a radar type sewer level sensor. So the LSTT allows us to not just work with some of the bigger meters, but also a wide range of other types of sensors found across a water utility. So moving on from the external devices that Taggle offers for use with smart water meters, or to make existing meters smart water meters, now focus on some of the more recent developments, which are a couple of water meters with integrated Taggle radios. Honeywell, the Fortune 100 company out of the US, recently bought Elster Australia, along with Elster Worldwide, and are now the owners of the very famous V100 and V200 meters. So impressed was Honeywell with Taggle's expertise demonstrated here in Australia that they saw fit to engage us to build our radio into their electronic registers. And so what we've introduced last year is the V200 HT, which you see in front of you. This is available in DN20 and DN25 sizes, and will soon be available also in DN32 and DN40. But it is effectively a mechanical meter with an electronic register with a built-in Taggle radio. It's an all-in-one unit which can very simply be used to replace an existing water meter. It's size for size with an Elster V100, so it's a standard size and it's extremely easy to install. One of the neat features about the V200 HT is the fact that it's also fitted with an NFC radio, that's Near Field Communications Radio, which allows a water service provider operator to go up to the meter and interrogate the meter for current readings, to start a transmission, or indeed to download the last 8 readings of data. This can be very useful for field operatives. The second new product, which is also an integrated meter, comes from Akiba, based in Queensland. Their claim to fame is having developed a DN20 electromagnetic flow meter. For quite a while, Akiba and Taggle discussed the idea of building a Taggle radio, and this all came to pass a little time ago, and these units are now actually being installed for a council in New South Wales, where they had both potable and raw water reticulation networks. And so this product being suitable for both potable and raw water made it very well suited to the task. We expect that there will be a lot more use of this around Australia in the future. So Taggle is a growing company, and its technology is evolving. And not resting on our laurels, we are now in the throes of introducing the next generation of Taggle devices. These three shown on the screen at the moment are those that are just about to be released. In fact, I think the Parakeet, the one in the middle, is already released in the US. But they have taken the best, if you like, of the original or the first generation of Taggle devices and added onto them some of the lessons we've learned over the years in terms of what our customers want and what makes sense for the more efficient operation of these types of devices in the field. I guess the two most significant, well, actually there's three significant factors in these new devices. The first is the housings. The housings have been redeveloped to provide for better protection against water ingress. Anyone that works with devices that are out in the environment will know that preventing water ingress is a major challenge with any electronic device. And we have learned from our experiences in the past and developed a whole new way of building these things such that the challenges of water ingress will be greatly reduced. The second is in terms of battery life. These units have, generally speaking, 15 years battery life, although the Parakeet in the middle, I believe, has a 20-year battery life for use in the US. They have a slightly different view on meters in the US and demand a much higher battery life for devices to be connected to them. The third thing is that they all have this NFC radio capability to allow for configuration in the field. And with the Cockatoo on the right, it is perhaps one of the most exciting of our new products in that not only is it capable of operating with the Taggle radio network, but it can also be fitted with other radio devices, for example, LoRaWAN or NB-IoT. I won't go into details on that just now. If anyone has any questions about it, very happy to answer them later in the program. So, coming to the end, just wanted to bring to your attention the fact that Taggle Systems has, through its relationship with Honeywell in the US, come across an opportunity to distribute a product in Australia, which we think is going to be extremely useful. The company in the US is called Nicor, and their speciality is manufacturing polymer lids and pits for use in utilities, whether it be water, gas, or electricity. We saw value in striking up a relationship with Nicor because when we start installing our transmitters into pits in streets and in neighborhoods, very often they're made from a black plastic, and that black color comes from the use of carbon, which of course is a problem in terms of radio propagation. So Nicor lids are manufactured from a very special material, which in effect makes it transparent to radio signals. So what that means is that we can now get far better performance from our transmitters, which are installed in pits and similar situations, than ever before. And so we have decided to become the Australian distributor for this product, knowing that automatic meter reading and the use of all sorts of transmitters in pits is going to be a thing of the future. I'm not going to go into much detail on these now. We will do a presentation on them sometime later, possibly in a future webinar. But the other thing that I wanted to mention to you was about their pits. These pits are uniquely designed such that they can be broken apart and flat packed. So anyone that's worked with pits, you'll know what an absolute nightmare they are to transport and to store. They just take up so much space. The way Nicor has developed these things is such that they can be dismantled, flat packed and shipped en masse over long distances without any great cost or difficulty. So that kind of brings me to the end of what I have to say this afternoon, and I wonder if anyone has any questions. You can ask a question by typing in the group chat, and or if you wish, I can unmute everybody and everybody can ask a question if they wish. So over to you guys.
Yeah.
Spreadsheet up as well.
Yep. Oh, he's got one. It's
Okay, so I have one question from Michael. No, Michael, there's no update on the MyWater app today. Our next presentation will be a walkthrough, a demonstration, a live demonstration of MyWater, or Aqualis, which is its new name from tomorrow. So perhaps if you want to talk to us separately, or indeed tune in next week, Mark and Claro, I believe, will be Steve and Ty will be working through that in real time. Does the V200 have a dual check valve? It certainly does. They can be supplied, although I don't think it's legal, they can be supplied without check valves, but you can also have single or dual check valves. But the majority of the ones that we've installed so far have been dual check valves. Oh, these questions are coming thick and fast. Just a moment.
oh wait, no. So Mark said, yeah, my 2 cents.
Nick, are the sewer lids displayed trafficable? They certainly are, Nick. These units have been designed for use in streets.
Hey, Mark.
We are working through the process of Australian standards, but I do believe that we will be able to meet nearly all of the requirements for lids in Australia, including Class D. Kirley. If a meter that a logger is attached to gets changed, will the logger need to be sent back to Taggle to be fitted with an appropriate probe? Well, ideally, Kirley, yes, because the terminations made in our labs are far better than those we can achieve in the field. However, we realize that this adds to the complexity and the cost. And so it is possible to change a probe on a transmitter in the field. It just means a field termination, which is a little bit tricky to do, but it can be done by an accomplished technician. So yes, you can do that. What's the indicative price of the Cockatoo? Brad asks. I'm sorry, Brad, I don't know the answer to that just now, but I'm sure we can get back to you and ask you the question. And I'm sure one of my colleagues will write down that question and remind me later. So Richard asks, your approach to firmware upgrades, is the Akiba A210 certified? The A210 is certified, Richard, to NMI R49, if that's what you're asking. So yes, it is suitable for billing. Not quite sure about the firmware upgrades. Oh, yes, I do. Yes, now I understand what the question means. Generally speaking, Richard, our approach to firmware upgrades is that they shouldn't need to be done. The meter does one job, and unless something radical happens, there shouldn't be a need to change it over its life. However, particularly with the new generation, having the near-field communications ability, it will be possible to update the firmware, but it's not something that we would be promoting or recommending. Hendrik, when will the DN25 to 40 meters be available? You're talking about the V200 HT there, Hendrik. The DN25 is available now, I believe, and the 32 to 40s will be coming sometime later, but when, I don't know. Simon. Okay, so Simon asks, could I expand on the functionality of the Cockatoo and a Corella, which I didn't mention? Will they be able to dynamically change transmission interval, rainfall buckets, and so on? Yes, Simon, that is part of the plan, realizing that particularly when it comes to monitoring the performance of sewers and using rainfall information in conjunction with that, the new devices will allow for a change of transmission rate or update rate when, for example, there's a heavy rainfall, as you would experience in your area. Does the Cockatoo have the same inputs as the LSTT, Brad asks. Yes, I believe so, Brad. The Cockatoo is, in effect, a later development of the LSTT, and so I would expect it to have all of the functionality plus a bit more. Okay, any more questions? I did talk about voice, but I'm sorry I've been unable to make that happen effectively. So one more question. Belinda, what is the best way to avoid or reduce receiving intermittent interval data from the Taggle where communications are interrupted and data is accrued? Is there a Taggle that logs data at intervals and then transmits each at the timestamp data? Okay, so our approach to this, Belinda, is that every time a smart meter transmits and sends its data, not only is it sending its current reading, but it's also sending the previous two readings. So if the meter is set for hourly readings, it'll send the current reading plus the previous reading and the previous reading. So that's 3 readings every time, which provides an overlap and allows for missing readings to be updated. However, all of the readings are cumulative readings. That is to say, even if for whatever reason somebody parks a truck over your meter or something like that and you miss out on 2 days worth of updates, the reading that you get afterwards is the updated information. So you don't lose the currency of the meter reading. What you might miss on in that situation is the granularity of the data in between.
Talk to Dad.
So just a moment. Somebody has encroached upon my sound here. I hope that helps, Belinda. When the batteries are run down, is the whole transmitter replaced? Yes, Richard. The devices are designed to be IP67 or IP68, and it's nigh on impossible to make a device, particularly to IP68, that allows for field replaceable batteries without damaging the integrity of the protection. So the majority of Taggle's devices are IP68. So the MRC1, the ADC1, the HP1. Some of the devices can allow for batteries to be replaced. So the LSTT and the Cockatoo, they will have replaceable batteries. Okay, oh, what happened there? So we are getting towards the end of questions. If anybody does have any more questions, I think it's probably a good time to end there. It's now just gone 3:30. So unless anyone has any burning questions, I will call a halt there. And I thank you all very much for your attention this afternoon. There will be another weekly webinar happening next week. The subject of that, as I think I may have mentioned, is Aqualis. It'll be a live demo of the newly updated My Water interface, Aqualis being the new name for My Water. So anyone that has seen or has used My Water might want to tune in and see what the updated user interface looks like and get the lowdown from the man who creates it, Stephen Tai at Tyware. So that's about it for me, folks. I'm going to leave it there and wish you all good afternoon and see you next time. Thank you very much.